Hello, you're listening to Knowledge Before Sleep. Tonight, as the world around you slowly settles into silence, allow yourself to completely relax. Take a deep breath, feel the gentleness spread with each exhale, and let your mind float away into the vast expanse of the universe. Have you ever wondered where the gold ring on your finger or the sparkling diamond you've admired truly come from? We often think of them as treasures from the earth, but the truth is far more magical. Every speck of gold dust, every piece of that precious stone, carries within it the warmth of a star that has died, the legacy of a cataclysmic explosion that occurred billions of years ago. In the 20 chapters to come, we will journey back in time together to learn about the majestic lives of the stars. We will see how they are born from nothingness, how they forge precious elements in their own giant cosmic furnaces, and how their deaths sow the seeds of life and beauty on this earth. Close your eyes, listen to the slow, steady beat of your heart, and let me guide you to the answer to the question, how does a dying star create gold and diamonds? A story of endings that give rise to the most brilliant new beginnings. Chapter 1. The Cradle of Stars. Imagine yourself standing in the middle of a vast expanse, where the darkness is not emptiness, but a mysterious black velvet curtain enveloping all things. In the absolute silence of the cosmos, where sound cannot travel, something miraculous is quietly unfolding. The story of gold, of diamonds, and of the very air we breathe does not begin on solid planets, but in faint, misty clouds of dust wandering between distant galaxies. Scientists call these giant clouds nebulae. Viewed from afar, through the lens of the Hubble or James Webb telescopes, they appear like colorful works of art with ribbons of rose pink, deep blue, and violet interwoven. But as we draw closer, we see they are actually endless regions of space filled with hydrogen gas and tiny dust particles. These particles are too small for the naked eye to see, yet they are the very first building blocks of the entire universe we know. A single nebula can stretch for hundreds of light years. To help you comprehend this scale, remember that 1 light year is equivalent to about 9.6 trillion kilometers. It is a distance so immense that the human mind can barely grasp it. Within that giant cradle, everything seems to be in a deep slumber lasting millions of years. Hydrogen atoms float gently, occasionally bumping into each other before drifting apart again, as slow and unhurried as falling leaves on a windless afternoon. Yet, in that stillness, an invisible hand is silently shaping everything. That hand is gravity. Gravity is the most primordial force, a power of incredible persistence and patience. It begins to pull the dust particles and gas molecules closer together. At first, this pull is incredibly weak, just enough to alter the trajectory of a few tiny particles. But as the particles gather into a clump, their mass increases, and their pull on their surroundings becomes stronger. Imagine a crowd at a festival. Initially, people are scattered about, but when a few gather in one spot, others curiously approach, and gradually, the crowd becomes denser and denser at the center. In the universe, this process happens much more slowly, stretching over thousands, even tens of thousands of centuries. As the density at the center of the gas cloud becomes immense, something strange begins to happen. Silence gives way to commotion. Under the immense pressure of gravity, the hydrogen atoms are squeezed into an ever-shrinking space. They begin to collide with each other at increasing speeds. In the world of tiny particles, collision means heat. When you rub your hands together, you feel warmth. Similarly, when trillions upon trillions of atoms are compressed, they generate a massive amount of heat. The central region of the cloud begins to warm up from a few degrees above absolute zero to thousands of degrees Celsius. At this point, a glowing sphere begins to form at the core of the nebula. Scientists call this a protostar, a star in its infancy. It cannot yet shine as brightly as the sun, but it has begun to radiate a warm, infrared glow through the thick veil of dust. Around this protostar, the rest of the gas cloud starts to rotate, forming a giant flat disk, like the wide, flat skirt of a dancer performing a spectacular spin in mid-air. This rotating disk can be billions of kilometers wide. In its distant outer regions, the cold still reigns, but near the center, the pressure has built to a suffocating level. Gravity is no longer simply pulling particles together. It is now trying to crush everything. It is the struggle between the inward crush of gravity and the outward push of thermal pressure that creates a delicate balance, a gentle first pulse of life in the universe. Imagine you are observing this process from a safe distance, about 160 billion kilometers away. You would see a huge dark region being slowly torn apart by a faint glow from within. That is the sacred moment when a star is trying to break free from its cocoon to be born. To reach this stage, the universe has taken about 10 million years, a tiny number compared to the age of a galaxy, but an entire epic poem for human existence. As time goes on, the temperature at the core of the protostar rises dramatically. When the temperature hits the threshold of 10 million degrees Celsius, an invisible boundary is crossed. At this temperature, hydrogen atoms no longer just bump into each other. They are slammed together with such force that their protective shells are broken, and they merge to form a new element, helium. This is nuclear fusion, the eternal energy source of the stars. In that moment, the star is truly born. A brilliant and intense burst of light radiates outward, clearing away the surrounding layers of dust and announcing its presence to the vastness of space. This young star will spend most of its life performing the work of a great alchemist, transforming simple elements into more complex ones. And from that fiery core, the very first atoms of carbon, of oxygen, the elements that make up your body, begin to form. Now, take a deep breath and feel the serenity of the night. You see, even the greatest stars begin with tiny specks of dust and the patience of gravity. Nothing is rushed in this universe. Everything needs time to mature, to accumulate energy, and to shine. The silence of the nebula is the beginning of all beauty, the peaceful cradle for the wonders yet to come. As we end this chapter, we have seen our small star announce its birth with its first cry of light. It stands before a long journey of billions of years, a journey full of turmoil, but also of immense brilliance. Let the image of colorful nebular ribbons and the warm light of the young star soothe you into sleep. In the next chapter, we will explore the symphony of gravity, where the star enters its most radiant youthful years, and learn how the power hidden within it can resist the crushing force of an entire galaxy. Chapter 2. The Symphony of Gravity. After the first burst of light flares up, dispelling the misty veil of the nebula, our young star enters a new phase of its life. If the previous chapter was a tumultuous beginning, this chapter is a harmonious and delicate symphony of the greatest forces in the universe. This is when the star finds stability, a miraculous state of equilibrium that scientists call a star's prime. Imagine the star now as a giant creature breathing in a steady rhythm. To sustain its existence, it must face a relentless battle between two opposing forces. On one side is gravity, the silent giant we have already met. Gravity has only one desire. It wants to pull everything into the center, to crush the star into a single tiny point. If nothing stood in its way, gravity would destroy the star instantly with its immense, crushing power. But on the other side, right at the star's core, a counteracting force has emerged. It is the pressure from tremendous nuclear explosions. As trillions upon trillions of hydrogen atoms fuse into helium, they release a colossal amount of energy in the form of light and heat. This energy creates an incredibly strong outward push. You can picture the star like a giant balloon. The skin of the balloon always wants to contract, but the hot air inside is constantly pushing out, keeping the balloon full and round. This balance between the inward pull and the outward push is the secret that allows stars to shine steadily for billions of years. During this time, the star does not grow or shrink significantly. It stands firm in the vastness of space, radiating warmth and light to the planets around it. For an average-sized star like our Sun, this stable phase can last for up to 10 billion years. It is a period of time so long that if we consider the life of the universe to be a single day, then all of human existence would be like the faintest blink of an eye. Let's look deep inside the core of this powerhouse. There, the density of matter is almost unimaginable. A piece of matter the size of a pea from the star's core would weigh as much as a large truck on Earth. In that dense environment, heated to 15 million degrees Celsius, Particles no longer move according to ordinary laws. They perform a frantic dance, colliding with each other at speeds of thousands of kilometers per second. It is these collisions that are the source of all life and also the stepping stone for the later creation of gold and diamonds. Although the core is a true inferno, the star's exterior appears serene and poetic. The light created in the core cannot escape immediately. It must undertake an arduous journey, bouncing through the dense layers of matter, taking tens of thousands of years to reach the surface and soar into space. When those rays of light finally escape, they carry the message of life. If a planet is located at just the right distance, say about 150 million kilometers away like Earth, that light will bring warmth, allowing green plants to flourish and deep blue oceans to form. During this stage, the star is essentially a diligent blacksmith. However, at this point, it is only using the simplest materials. It consumes about 600 million tons of hydrogen every second, converting it into about 596 million tons of helium. Do you wonder where the remaining 4 million tons of matter went? They didn't disappear. They were converted into pure energy, according to the great scientist Einstein's formula. It is those 4 million tons of matter lost every second that light up the night sky and warm our souls. Relax your mind and feel the rhythm of this symphony. The universe is not as chaotic as we might think. It operates on laws of absolute balance. Gravity and nuclear pressure, darkness and light, contraction and expansion all intertwine to create a state of powerful stillness. The star now is like a person in deep meditation, tranquil on the outside, but with a powerful current of life force flowing within. If you look up at the sky on a clear, quiet night, remember that each of those tiny specks of light is a symphony just like this. There are stars hundreds of times larger than our sun, emitting an elegant blue light but consuming their fuel very quickly. Then there are small, humble stars with a faint red light, but they can live for trillions of years, enduring with patience through the countless ebbs and flows of time. This stability is necessary because this is when the universe is nurturing the elements. Although gold and diamonds have not yet appeared at this stage, the foundation is being laid. If the star did not have this long period of vitality, life would not have enough time to blossom on planets, and we would not be here to tell each other this story. Let your mind drift along the endless streams of energy radiating from the star's center. Feel the power of gravity gently embracing everything, and feel the warmth of the fusion reaction spreading out. Everything is happening exactly as it should, unhurried and full of confidence. Our star still has a great deal of time before the truly momentous changes begin. But you know, no symphony lasts forever without a crescendo. This balance, no matter how perfect, is based on a finite fuel source. One day, the hydrogen in the core will begin to run out, and this gentle symphony will have to move on to a new, more dramatic chapter. That is when the star begins to reveal its nature as a true alchemist, starting to forge heavier, more complex elements. We will close the chapter on stability here. The star continues to shine brightly above, guarding the peace of space. In the next chapter, we will delve deeper into its internal engine to better understand how tiny atoms made a great leap to become precious materials. Our journey in search of gold and diamonds has only just begun to take its first steady steps. Chapter 3: The Great Engine of the Universe. In the silence of the night, as we look up at the tiny specks of light in the sky, it's hard to imagine that each of those specks is actually a colossal nuclear reactor operating with unbelievable power. If the previous chapter showed us the star's miraculous balance, this chapter will open the door that leads deep into its core, where the engine of the universe is working tirelessly to create light, heat, and the very seeds of precious materials. Imagine you are traveling to the center of a star like our Sunday. The deeper you go, the more the darkness recedes, replaced by a region of such extreme brilliance. Here, the concepts of solid, liquid, or gas that we know on Earth completely disappear. Everything exists as a dense soup of matter called plasma, where atoms are stripped of their outer shells, leaving only bare nuclei. At the star's core, the temperature reaches 15 million degrees Celsius. The pressure here is 300 billion times greater, than the atmospheric pressure we breathe on the ground. In this harsh environment, hydrogen nuclei, which are essentially single protons, move at terrifying speeds. Normally, these particles carry a positive charge and would fiercely repel each other like the identical poles of two powerful magnets. They never want to touch. However, the star's engine performs a physical miracle. Under the immense pressure of millions upon millions of tons of matter pressing down from the outside, the hydrogen nuclei are squeezed so tightly that they have nowhere to retreat. When the distance between them becomes incredibly small, less than a trillionth of a millimeter, a new force emerges. This is the strong nuclear force. This force is like the universe's superglue. It overcomes the electromagnetic repulsion and locks the nuclei together in an eternal embrace. This process is called nuclear fusion. When 4 hydrogen nuclei combine to form one helium nucleus, something miraculous happens. The newly formed helium nucleus is actually slightly lighter than the total mass of the 4 original hydrogen nuclei. That lost mass doesn't just vanish into thin air. It has transformed into a source of pure, intense energy. Every second, our Sun alone carries out this process with 600 million tons of hydrogen. The result is 596 million tons of helium, with the remaining 4 million tons of matter converted into energy. To give you an idea, the amount of energy released each second is equivalent to billions of atomic bombs exploding at once. This is the power that illuminates the entire solar system, brings life to our planet, and is the engine that helps the star resist the crushing force of gravity. The energy is created in the form of tiny particles of light called photons. However, the journey of light from the star's core to its surface is not as easy as we might think. In the dense environment of the stellar core, these light particles are like a lost traveler in a maze with no exit. They travel an extremely short distance before colliding with another particle of matter, getting knocked off in a completely random direction. Scientists call this the random walk of light. A single photon can take anywhere from 10,000 to 170,000 years just to travel from the core to the surface, a distance of only about 700,000 kilometers. This means that the sunlight warming your skin today was actually born back when humans had not yet formed ancient civilizations. It has waited patiently, weaving through layer after layer of matter to finally be free to fly into the vastness of space. Take a deep breath and feel the grandeur of this process. The star's engine never rests. It works silently but tirelessly, consuming fuel methodically to sustain life. It is thanks to this giant furnace that the universe escaped the darkness of its early days. The light from the first fusion reactions tore through the darkness, allowing us to see the beauty of galaxies and nebulae. And you know what? This very engine is also where precious metals begin. In this chapter, the star is only creating helium from hydrogen. This is the first, simplest, but also most crucial step. Without this step, the star would not have enough energy to survive and advance to the next stages, where temperatures are even higher and pressures even more immense, enough to forge carbon, oxygen, and later, gold and diamonds. The beauty of science is that it doesn't take away the romance of the universe. Instead, it shows us the deep connection between the smallest things, like atomic nuclei, and the grandest things, like a star. We are living on the waste products of this engine, that is, light and heat. And later, when the star dies, everything it has painstakingly manufactured within itself will be released, creating treasures for the next generations of planets. Relax your shoulders and feel your steady breath sync with the pulse of that great engine. Everything in the universe is running smoothly, according to precise and harmonious laws of physics. There is no need to rush. The star will continue to shine, continuing to perform its miracle of fusion for billions more years, guarding our peace. When one chapter ends, a new one begins. We now understand how a star operates, but the life of such a magnificent entity is not filled with only peaceful years. The time will come when that abundant supply of hydrogen fuel begins to run out, forcing the engine to change how it works in order to survive. That is when the most wondrous and incredible transformations truly begin. In the next chapter, we will follow the star as it enters its middle age, where it begins to face the first challenges of its finite existence. and also when the first building blocks of more complex life are formed. Hold on to this stillness and let your mind continue to journey with me through the dust clouds of the galaxy. Chapter 4. The Peaceful Years. After overcoming the turbulence of its formative period and igniting the nuclear engine in its core, our star enters a phase that astronomers call its adulthood. Imagine this as the most brilliant and stable youth of a star, where everything proceeds calmly and steadily, like the breathing of someone deep in a peaceful sleep. During this stage, the star is like a devoted and patient guardian. For an average-sized star, like our Sun, this peaceful period lasts for about 10 billion years. To help you visualize this enormous number, consider that if the entire history of the universe, from its beginning to the present day, were condensed into 1 year, a star like the Sun would spend more than 6 months just staying in one place, shining steadfastly. This is when the balance we spoke of in the previous chapter reaches absolute perfection. Gravity still pulls silently inward, and nuclear pressure still pushes powerfully outward. These two forces oppose each other, but neither overpowers the other, creating a powerfully tranquil state. The star no longer contracts or expands suddenly. It stands there, firm in the cosmos, like an eternal lighthouse, guiding the tiny planets around it. Join me on a more delicate journey into the outer layers of the star during these years. Although the core is where violent reactions take place, it takes tens of thousands of years for that energy to work its way to the surface. As it nears the outermost layer, the way the energy travels changes. It no longer just bounces between particles, but begins to churn like bubbles in a pot of soup simmering on a stove. Streams of hot gas rise from the depths, carrying heat, and then, having cooled slightly at the surface, they sink back down to make way for new streams. This process occurs continuously, creating a stellar surface that is vibrant yet incredibly orderly. If you could look closely at this surface through a special filter, you would see it resembling a brilliant golden field with tiny granules constantly in motion, emitting a warm and gentle light. It is this stability that has allowed life to blossom. Think about our blue planet. Earth is about 150 million kilometers from the Sun, a distance just right to be neither too hot nor too cold. For over 4 billion years, the Sun has provided a nearly constant amount of energy. It is thanks to this faithfulness and persistence that the oceans did not freeze. The atmosphere was maintained, and the first seeds of life had enough time to evolve from simple cells into complex beings like us today. The star at this point is not just a reactor, it is also a gentle mother. It shelters its planetary children with a giant embrace of its magnetic field. This embrace protects us from harmful cosmic rays and powerful stellar winds. Although the star sometimes has moments when it sneezes, creating streams of charged particles that travel billions of kilometers, on the whole, it maintains absolute safety for everything within its system. During this adult phase, the star silently continues its work of crafting helium from hydrogen. Although we are looking forward to the appearance of gold and diamonds, remember that the universe is never in a hurry. All beauty requires accumulation. These 10 billion years of quiet shining are when the star prepares the ingredients and energy for the miraculous leaps to come. It's like an artist who spends a lifetime learning and training before creating a masterpiece in their final moments. Interestingly, the smaller and more humble the stars are, the longer this peaceful phase lasts. Red dwarf stars, many times smaller than the Sun, can shine steadily for trillions of years. Meanwhile, giant stars, which live more extravagantly, consume their fuel very quickly and only live for a few million years. Our star chose a middle path, brilliant enough to bestow life, yet patient enough to accompany us through the long stretches of history. Let your mind settle, feel the steadfastness of the light that envelops space. There is nothing to worry about, nothing to rush. The star is still there, its breathing is still steady, and its energy source is still abundant. We are in a golden age of stability, where everything seems perfectly arranged for us to sit here and contemplate the beauty of the universe. But you know, even the most peaceful years must eventually change. Deep within the star's core, the ash from the fusion process, which are helium atoms, is gradually accumulating. They are heavier than hydrogen, and do not participate in the reaction at the current temperature, so they silently sink to the center. These are the seeds of change. When this amount of ash becomes too large, the star structure will begin to be shaken. To end this chapter, let us appreciate the quiet years of the stars. It is thanks to their persistence that the universe is not just a place full of explosions, but also a warm home for life. The light you see today is a testament to the star's steadfast promise to the space around it. In the next chapter, we will witness the first signs of change. As the precious hydrogen fuel in the core gradually runs out, the star will face the first crisis of its life. That is also when it will begin to reveal its nature as a great alchemist, preparing for the process of creating heavier elements, paving the way for the appearance of diamonds in later chapters. Our journey is still very long, and every step brings new wonders. Take your time, and let your thoughts of distant stars guide you into a state of utmost relaxation. Chapter 5. As the fuel runs low, for billions of years, our star lived an incredibly generous life. It continuously bestowed light and warmth into the vast expanse of space, thanks to the abundant hydrogen fuel in its core. However, just as even the largest candle must eventually burn down to its last drops of wax, the star begins to face depletion. This is not a sudden end, but a transformation that is both subtle and dramatic. Let us return to the center of the star, to what we call the nuclear furnace. After billions of years of fusion reactions, the star's core is no longer as pristine as it was at birth. Every second, millions of tons of hydrogen have turned into helium. Helium now acts like a layer of ash, accumulating after a warm night by the fireplace. Because helium is heavier than hydrogen, it doesn't float, but slowly sinks, gathering right at the center of the stellar core. The problem is that at the current temperature of 15 million degrees Celsius, helium is just a kind of passive ash. It cannot participate in reactions to create energy. It just sits there, taking up space and diluting the precious remaining hydrogen fuel. Imagine a car on a long journey, but its gas tank is not only emptying, but also being filled with incombustible sand. The star begins to feel the first signs of fatigue in its great machine. When the hydrogen at the very center is completely depleted, the nuclear engine there abruptly ceases to operate. This shutdown has an immediate consequence. As we learned in previous chapters, a star exists because of the balance between the outward push of energy and the inward pull of gravity. Now, as the push from the core weakens, gravity, the most patient entity in the universe, immediately seizes the opportunity. With nothing to stop it, gravity begins to crush the stellar core, causing it to contract powerfully. But the universe always contains interesting paradoxes. The very moment gravity squeezes the stellar core is when a new source of energy is born. When matter is compressed to an extremely high density, it heats up tremendously. The star's core, already very hot, now becomes more brilliant than ever under its own pressure. The temperature here begins to surpass the threshold of 15 million degrees Celsius, climbing towards ever higher milestones. The incredible heat from the contracting core radiates out to the surrounding layers, where there is still plenty of unused hydrogen. In a region right around the helium core, the temperature rises high enough to trigger a new round of hydrogen fusion. Scientists call this process shell burning. Instead of burning at its center, the star is now like an orange, with a core that is cooling down in terms of reaction, but is physically scorching hot, surrounded by a thin, brilliantly burning shell. It was this burning shell that created a flow of energy more powerful than any during the star's youth. The outward push now becomes fierce and uncontrollable. It pushes the star's surface layers of gas farther and farther out into space. The star begins to swell unnaturally. If you were watching from a distance, you would see its color begin to change. From the brilliant yellowish white of its youth, it gradually turns to orange, then a pale red. The reason for this color change is easy to understand and deeply artistic. As the outer shells are pushed further away, the energy has to spread out over a much larger surface area. The surface temperature therefore drops, causing the light it emits to take on a reddish hue, the color of coals that have begun to cool but are still smoldering. Our star is taking its first steps into a glorious yet tragic phase, the stage of becoming a red giant. This phase of dwindling fuel is a reminder of the laws of time. Even the most powerful entities must obey the cycle of creation. However, this crisis is not meaningless. The contraction of the core and the rise in temperature are the very prerequisites for the star to make its next great leaps. Without the depletion of hydrogen, the star would forever only create helium, and we would never have carbon for life or gold for precious jewelry. Imagine the star now as an artisan, gathering all their final efforts to prepare for a climactic performance. It is accumulating heat, accumulating pressure, waiting for the moment the core becomes hot enough, 100 million degrees Celsius, the flashpoint for the helium ash, to begin to burn and create new elements. It is a silent but incredibly fierce preparation beneath a seemingly slow expansion. In the silence of space, these changes unfold over millions of years. To us, that is an eternity. But to the universe, it is just the prelude to an epic of rebirth. The star is sacrificing its old, stable form to pave the way for a more complex, materially richer structure. The specks of gold and diamond dust that we seek are slowly being formed from these very moments of the star's hardship. The atmosphere around the star now becomes thinner but immensely vast. If this were our sun, it might have already swallowed the planet Mercury and would be closing in on the planet Venus. The majesty of a red giant begins to loom, heralding a new era for its surrounding planetary system. An era where beauty comes with brutality, and life must give way to the grand processes of atomic transformation. Just let your mind drift with the expansion of that glowing red star. Feel the heat from its burning shell and the menacing stillness of the contracting core. Everything is moving according to nature's perfect plan. There is no waste here. Every lost hydrogen atom is an investment in the heavier elements that will be born in the future. We will close this chapter as the star stands on the threshold of its greatest change. The fuel at its center is depleted, but the fire still rages in its shell. And a new factory is about to be inaugurated right at the heart of the collapse. What happens next will be even more magnificent as the star truly becomes a red giant, ready for higher level nuclear reactions. In the next chapter, we will witness the powerful rise of the red giant and learn what will happen to the neighboring planets as their star extends its arms to embrace them all. It is a story of an end, but also the beginning of a new richness for the universe. Our journey continues, gently and profoundly, like the flow of time itself. Chapter 6. The Rise of the Red Giant. When the hydrogen in its core is exhausted, the star does not simply fade into silence. Instead, it resists death with an explosion in size that is difficult for the human mind to imagine. Imagine our star, already immense, suddenly swelling up, extending its arms across the surrounding space. This is the moment it becomes a red giant, an entity that is both magnificent and carries destructive power for anything that lies too close. This expansion occurs slowly but irreversibly. If that star were our sun, it would begin to swallow its own faithful children. First would be Mercury, the tiny planet closest to it, which would be enveloped by a wave of scorching gas and vanish completely. Next, Venus, the planet that shines like a morning jewel, would suffer the same fate as its thick atmosphere is torn apart by the heat of thousands of degrees. The star will have expanded its size 100 times, then 200 times its original scale. At this point, the diameter of the red giant can reach hundreds of millions of kilometers. If you were to look back from a distant planet, you would no longer see a sharp, round disk, but a colossal, glowing red and hazy sphere, dominating an entire corner of the sky. This red color isn't because it's hotter than before, but because its surface has actually cooled down. As the layers of gas are pushed too far from the heat source in the core, they lose energy and shift from a yellowish-white to a deep red, like the color of embers fading in the cold night. But don't let that gentle red color fool you. Although its surface has cooled to only about 2000 to 3000 degrees Celsius, the total amount of energy the red giant radiates is thousands of times greater than when it was young. That's because its surface area is now so immense. It's like a heater that has been expanded to fill the entire room. Though the flame itself isn't too intense, the heat it radiates still envelopes every corner. Inside this enormous, tenuous corpse, A silent war is still being waged in the core. While the outer shells relentlessly expand into space, at the center, gravity is doing the exact opposite. It crushes the helium ash with extreme pressure. The core of the red giant is now tiny, but incredibly dense, containing the mass of tens of thousands of Earths, but packed into a space equivalent to a small planet. It is this contrast extreme expansion on the outside and intense contraction on the inside that creates the strange structure of this phase. For Earth, the prospect of its host star becoming a red giant is a sad epic. As the Sun expands to near our orbit, about 150 million kilometers, the blue planet's atmosphere will be completely blown away. The oceans, the cradle of life, will evaporate in the blink of an eye, leaving behind barren and scorching basins. Earth will then be like a red-hot piece of coal, drifting in the thin gas of the very mother star that once nurtured it. But take a deep breath and don't worry too much. This is the inevitable law of cosmic evolution. The passing of an old order is a necessary condition for new and more precious things to emerge. While the red giant is busy expanding its domain, deep in the core, the temperature is silently rising. Hour by hour, day by day, from 15 million degrees, it gradually climbs to 30 million, 50 million, then 80 million degrees Celsius. The universe is preparing for a landmark event. When the temperature hits the 100 million degrees Celsius mark, another miracle of cosmic alchemy will occur. The helium core, considered ash for billions of years, will suddenly ignite. This is not ordinary combustion, but a thermonuclear explosion taking place in the confined space of the stellar core, creating elements like carbon and oxygen. It is carbon, the seed of sparkling diamonds, and also the foundation of all organic life, that is being forged in these dramatic moments. The red giant is not just a destroyer of planets. It is also a great cosmic crucible, preparing to give birth to the most essential materials. Its rise marks the moment the universe begins to transform from simple elements to complexity and richness. Feel the rhythm of this change. It is not rushed, but unfolds over millions of years, like a slow, deliberate transfer of power. Billowing currents of red gas churn on the star surface, creating bizarre and magnificent shapes. It is the beauty of a full bloom, of a flower blooming to its fullest before wilting to produce seeds. Every speck of dust blown from the red giant carries with it memories of a bygone era, while also containing hope for new worlds that will form in the distant future. In the silent night, let your mind be enveloped by the warm red hue of that giant star. Though it may seem terrifying with its extraordinary size, it is an indispensable part of the chain of life. Without this expansion, without the contraction of the core, the very carbon atoms in your body would never have been created. We are children born from the greatest upheavals of the stars. The symphony of the red giant is reaching its most climactic notes. The pressure in the core has reached its limit, and the temperature is ready for the final leap. The star is holding its breath, waiting for the moment when helium will ignite, opening a new chapter in the cosmic alchemist's kitchen. We will close this chapter with the red giant at the peak of its power, shining brilliantly and dominating space. In the next chapter, we will step inside that fiery kitchen to see how heavier elements are formed from the helium ash and how the very first diamonds begin to emerge from the darkness. The journey through the wonders of the universe still has many exciting things waiting up ahead. Stay relaxed and let your imagination continue to soar. Chapter 7. The Alchemist's Kitchen. We've witnessed our star swell into a red giant, engulfing a vast region of space. But that magnificent exterior is just a facade for an even greater event quietly building in its deepest core. If a star's life is a creative journey, then this is the moment the artist steps into their secret kitchen, where the first elements of life and sparkling diamonds are truly forged. Imagine you are drifting into the core of this giant star. The space around you is no longer made of thin wisps of gas, but a dense, suffocatingly heavy mass of matter. Gravity is no longer a gentle companion. It is now delivering its most powerful squeeze yet. The helium core, the ash of billions of years past, is being compressed so tightly that atomic nuclei are nearly touching, ready for an explosion of creation. The temperature has now reached an unimaginable milestone, 100 million degrees Celsius. At this temperature, all the normal rules of matter are broken. The once lazy helium nuclei now begin a frenzied dance. They hurtle into each other at thousands of kilometers per second. However, to create carbon, the foundational element of diamonds, the universe needs a strangely perfect arrangement. Scientists call this a beautiful name, the triple alpha process. Picture it like this. Two helium nuclei collide and merge for a brief moment, just a millionth of a billionth of a second. In that fleeting instant, before they can separate, a third helium nucleus must rush in and join the party immediately. These three nuclei fuse into one, and from that, a brand new carbon atom is born. This is a moment of magic. It's an incredibly unlikely coincidence, yet it happens billions of times every second within the star's core. The alchemist's kitchen is now operating at full capacity. From simple helium atoms, the star has crafted carbon, the very thing that, billions of years later, will become the core of your body, of lush green trees, and of the hardest diamonds in the world. But the star doesn't stop there. Once there is enough carbon, other helium nuclei continue to collide and fuse with carbon to create oxygen, the element we breathe, to sustain our lives every day. The cosmic kitchen is now filled with the most precious ingredients. Each atom created releases an enormous amount of energy, creating a powerful thermal current that pushes back against the crush of gravity, keeping the star from collapsing completely. During this phase, the star truly becomes a generous mother. It not only shines to warm space, but it is quietly cooking the very essence of matter. Take a slow breath and feel this magical connection. Every oxygen molecule entering your lungs, every carbon atom in each of your cells, was all once forged in the 100 million degree furnace of some giant star billions of years ago. We are not just observing the universe, we are a part of it, carrying the blood and warmth of the stars within us. This helium fusion event happens so intensely that it is sometimes called the helium flash. Although the name sounds violent, from the outside we only see the star brighten slightly and become more stable for a short period. This is when the star enjoys the final fruits of its creation. It no longer has to worry about running out of hydrogen because it now has a new source of fuel, a new menu in its kitchen. However, remember that to get diamonds, carbon must undergo a far more intense compression process. In this chapter, we are only at the ingredient mixing stage. Carbon is being formed and is floating within the blazing red star. They are like precious seeds, waiting for the right moment to crystallize into eternal beauty. Imagine the streams of carbon and oxygen swirling inside the star's core, like rivers of light. They move in complex orbits, colliding and blending together under the halo of extreme temperatures. The alchemist's kitchen never rests. It is the embodiment of the universe's persistence and power of rebirth. Even when facing its own end, the star chooses to leave behind the richest legacy possible. As you lie here, in the silence of the night, let your mind listen to the pulse of that great factory. There is no clatter of machinery, only the smooth operation of physical laws and the magical combination of fundamental particles. Our world is so rich and diverse, yet it all stems from a simple recipe in that blazing red kitchen. This helium burning phase will last for about 100 million years, long enough for the star to accumulate a large amount of carbon and oxygen in its core. But then, just as all parties must come to an end, the helium supply will also begin to run out. At that point, the star will have to face a harsher reality. It no longer has enough heat to fuse carbon. But that very pause opens a hopeful new chapter for the formation of diamonds. When the fire goes out, pressure will do the rest of the work. The carbon atoms that the star has painstakingly created will be compressed, preparing for their transformation into the most stable crystal structures in the universe. We will close the chapter on the alchemist's kitchen here, as the first carbon atoms have been successfully formed. Our star has fulfilled its duty as a creator. It has transformed useless ash into precious raw gems. Its light now carries a more mature and profound beauty than ever before. In the next chapter, we will witness the gentle farewell of medium-sized stars. We will learn about the birth of beautiful planetary nebulae and how small stars end their lives to become sparkling diamonds in the galactic darkness. Our journey continues to flow gently, like a river of light, guiding you into a peaceful sleep. Hold on to this warmth, for you are a part of that grand story. Chapter 8. The Last Breath of Small Stars. In the vast universe, death isn't always a cataclysmic explosion. For small or medium-sized stars like our Sun, the end has an incredibly graceful beauty, like a long, serene breath after a hard day's work. When the energy from fusing helium in the core begins to run out, the star no longer has the strength to maintain its form as a ferocious red giant. It begins to enter its final phase, where it sheds its brilliant cloak to return to the cosmic dust. Imagine the star now is like a dandelion in the wind. Its outermost layers, which have expanded far out and become thin and light, are no longer tightly bound by the core's gravity. The star begins to make slow, powerful pulses. Each pulse pushes a portion of its material further out into zero-gravity space. This process unfolds leisurely over tens of thousands of years, creating shimmering filaments of gas and dust that surround the shrinking stellar core. Astronomers call this phenomenon by a very poetic but also somewhat misleading name, a planetary nebula. In reality, they have nothing to do with planets. The name comes from hundreds of years ago, when scientists looked through early telescopes and saw round, greenish halos that looked like the planets Uranus or Neptune. But in fact, it was the last breath of a dying star, a giant silk curtain woven from light and gas. When you observe a planetary nebula through the lens of the Hubble or James Webb telescopes, you will be stunned by its beauty. Some nebulae look like the wings of a giant butterfly spreading across the void, others like a mystical eye staring into the infinite, or like ethereal smoke rings blown by a giant. Their colors are a brilliant symphony: red from hydrogen, green from oxygen, and violet from other elements. These are all the precious materials the star painstakingly forged over billions of years. Right now, the star is performing a noble duty. It is scattering its seeds into space. The carbon and oxygen atoms that we saw in the kitchen in the previous chapter are now released. They drift far away, mixing into the cold clouds of interstellar dust. It is these very dust particles that billions of years later will gather to form new solar systems, new planets, and even new living beings. The final breath of the star today is the beginning of life tomorrow. While the outer shell is radiating out like a magnificent halo, at the center, the star's remaining core is undergoing a miraculous transformation. With no more nuclear reaction pushing outward, gravity begins to compress this core with terrifying force. From a giant sphere, it is crushed down to a size equivalent to our Earth. However, don't let that small size fool you. The entire mass of a great star is now compressed into a tiny space, creating an object so dense it's hard to believe. This object is called a white dwarf. A small spoonful of material from a white dwarf can weigh as much as a 15-ton truck on Earth. It glows with a pure, blue-white color, radiating the residual heat from billions of years of burning. A white dwarf is no longer a living star. It is a radiant stellar corpse, an eternal ember of the universe. It stands there at the center of the splendid planetary nebula, like a rough diamond waiting for time to polish it. Take a deep breath and feel this stillness. Do you see it? The star's passing isn't colored by decay. It is a sacrifice. The fragile, expanding shell carries with it the hope of new worlds, while the tough core remains as a testament to the power of existence. The planetary nebula will only exist for about 10,000 to 15,000 years, a very short time compared to the life of a star, before it completely dissolves into darkness, leaving behind the lonely and proud white dwarf. For stars with a mass similar to our Sun, this is how they leave their mark. They don't choose to explode and destroy everything, but rather to gently dissolve. It is in this dissolution that the building blocks of life are sown throughout the galaxy. Without these final breaths, space would forever be an empty void of hydrogen and helium, and there would never be solid rocky planets or deep blue oceans. Now, as you lie wrapped in the darkness of night, imagine yourself standing in the middle of a beautiful planetary nebula. Ribbons of purple and pink light are gently drifting past you. You can feel the last warmth from the white dwarf at the center. Everything is so peaceful, so gentle. The universe is recycling itself, turning death into life, turning ashes into the purest of seeds. The white dwarf we just mentioned is the key to finding diamonds in the universe. Because it's composed mainly of carbon and oxygen compressed at extremely high densities, over billions of years of cooling, it will begin to crystallize. A dying star doesn't just create stardust, it also leaves behind a giant diamond the size of a planet. But that is a long story of time and patience that we will explore more deeply in the chapters to come. To end this chapter, let's appreciate the beauty of planetary nebulae, the most magnificent paintings the universe has ever created. Our little star has fulfilled its mission perfectly. It lived a brilliant life and departed peacefully, leaving a precious legacy for all time. The faint light of the nebula is the goodnight wish that the stars send to the vastness of space. In the next chapter, we will go deeper into the darkness, where the white dwarf begins its slow transformation to become an eternal diamond in the heart of the cosmos. It's a journey from brilliant light to the perfect stillness of a crystal. Our journey continues to drift on, as serene as a beautiful dream. Let your mind continue to be soothed by the greatness and generosity of Mother Universe. Chapter 9: Diamonds in the Dark. As the colorful ribbons of the planetary nebula gradually recede into the darkness, the universe seems to grow quieter than ever before. At the center of that region of space, only a tiny object remains, sparkling with a pure, blue-white hue. That is the white dwarf, the radiant corpse of the star we've been following since the beginning of our journey. But don't let its small appearance, only the size of Earth, fool you. Deep inside this dense entity, one of nature's greatest miracles is quietly taking place. The formation of a giant diamond, the size of an entire planet. Join me in imagining the state of matter inside this white dwarf. Since there is no longer nuclear fusion to create outward pushing energy, gravity has delivered a final, powerful squeeze. The star's entire massive original bulk is now crammed into a space only about 12,000 kilometers wide. The pressure here is so immense that our minds can hardly comprehend it. It is millions of times greater than the pressure at the deepest part of the ocean or at the core of our planet. Under that tremendous force, the carbon and oxygen atoms, the waste products from the alchemist's kitchen we mentioned, are packed so tightly together that not a single gap remains. In its initial stage, a white dwarf is extremely hot. It retains all the heat accumulated from billions of years of burning in its past. However, with no more fuel to sustain it, it begins a long, drawn-out journey of cooling down. This is an incredibly slow process, taking billions, even tens of billions of years. And it is during this time, as the star slowly cools under extreme pressure, that the carbon atoms begin to perform a spectacular rearrangement. Here on Earth, we know that diamonds are formed when carbon is compressed deep underground with great heat and pressure. But what happens inside a white dwarf is on a scale many times grander. When the temperature drops to a certain point, the carbon atoms no longer move chaotically. They begin to find each other, locking together into an extremely perfect and stable cubic crystal lattice structure. Scientists call this process crystallization. Try to imagine you are looking into the core of this star. It's like the surface of a lake slowly freezing over as winter arrives, but instead of cold ice, this is a transparent, solid, and brilliantly shining crystal mass. The entire core of the white dwarf gradually turns into one giant diamond. A diamond not meant to be worn on a finger, but a diamond with a mass millions of times greater than our entire Earth. In the year 2004, astronomers actually discovered such an entity in the constellation Centaurus, about 50 light years away from us. They named it BPM 37093, but it's more affectionately and romantically known as Lucy. Inspired by a famous song about the sky and diamonds, Lucy is in fact a crystallized white dwarf with a diamond core weighing about 10 billion trillion carats. That's a colossal number that, if written out, would require a great many zeros following it. The existence of these diamond stars gives us a different perspective on death in the universe. Instead of a sad ending, the death of a small star is a filtering process that leaves behind only what is most pure and enduring. that giant diamond will exist almost eternally in the vast darkness. It no longer emits light through nuclear reactions, but simply radiates its remaining heat faintly until it cools completely and becomes a black dwarf, a cold, dark, and invisible diamond in the void. Take a deep breath, feel the stillness and patience of time. Diamonds are a symbol of eternity on Earth, but in the universe, they are proof of the miraculous transformation of matter. Carbon, the element that makes up black charcoal or soft graphite, under the molding hands of gravity and time, has become the hardest and most magnificent material. There is a deep connection between us and these diamond stars. Did you know? The carbon in your body shares the same origin from those stellar forges. Perhaps some of the atoms within us once lay in the core of a dead star, or perhaps in the distant future, when our sun ends its life in about 5 billion years, it too will leave behind a great diamond like this in the heart of the solar system. The journey of small stars ends like this, a quiet farewell that leaves behind a glorious legacy. However, the story of the gold we are searching for requires a different path, one more violent, more dramatic, and on an energy scale many times larger. Small stars may create diamonds through patience. But to forge gold, the universe requires the death of true giants. Let your mind immerse itself in the gentle, blue-white light of blue sea, the great diamond floating out there. Feel the certainty and stability of that crystal structure. Everything in the universe has its own place and value, from the finest dust particles to planetary diamonds. All are operating to a rhythmic symphony, guiding you into a state of absolute relaxation. We will close this chapter amidst the sparkle of diamonds in the dark. In the next chapter, we will bid farewell to the tiny stars to meet the proud giants of the universe. This is where the game becomes more dangerous, more brilliant, and where the first true heavy elements are forged in fire. May you continue to find moments of relaxation as we prepare to enter a new and dramatic phase of this stellar saga. Chapter 10. The Proud Giants. In the silent darkness, when we look up at the sky, there are points of light that are far more brilliant and magnificent than others. These are not gentle stars like our sun, but proud giants, the true rulers of the vast expanse. If the life of a small star is a serene instrumental piece of music, lasting for billions of years, then the life of one of these giants is a glorious, intense, but incredibly brief epic. To be called a supergiant, a star must have a mass at least 8 times that of the Sunday. Some are so massive, their mass is hundreds of times greater than our parent star. It is this colossal mass that seals a completely different destiny for them. In the universe, with greater size and mass come greater responsibility and a higher price to pay. These stars do not choose to live quietly. They choose to burn themselves out with the most furious intensity to illuminate an entire region of the galaxy. Imagine you are standing before a dazzling blue-white star like Rigel in the constellation of Orion. That blue hue is not a sign of coldness. On the contrary, it is a sign of an extremely high surface temperature, reaching tens of thousands of degrees Celsius. Because they are so massive, their gravity is terrifyingly strong, constantly trying to crush the star in an instant. To fight against that suffocating pressure, the nuclear engine in their core must operate at millions of times the power of the Sunday. Because they work so hard, these giants consume their hydrogen fuel at an unbelievable rate. If our sun is like a fuel-efficient car that can travel a very long road over billions of years, then these giant stars are like Formula 1 race cars burning through their entire tank of gas in a short amount of time. Instead of living for 10 billion years, they usually only exist for about 10 million years, or even less. 10 million years may sound long, but in the flow of the cosmos, it is merely the blink of an eye, a fleeting moment of brilliant glory. Inside the cores of these giants, the pressure and temperature are so immense that the process of cooking elements happens with incredible speed and variety. They don't just stop at creating helium from hydrogen or carbon and oxygen from helium. The tremendous heat allows them to go far beyond the limits of smaller stars. They begin to forge heavier elements like neon, magnesium, and silicon. Each layer of the star is like a layer of an onion, with the outermost layer still burning hydrogen, and the deeper you go, the more complex and hotter the nuclear reactions become. Their pride lies in that very splendor. These stars are often at the center of the most brilliant nebulae, creating powerful stellar winds that blow away anything in their path. They are the architects who sculpt the shape of galaxies. Yet, behind that magnificent beauty lies an underlying instability. Because they consume energy so quickly, their end often comes very suddenly and destructively. Try to relax your mind and envision a day in the life of a blue giant. It emits a stream of light so powerful, it can outshine tens of thousands of other stars around it. If a planet were to be too close to it, that planet would be vaporized in an instant. These stars were not born to nurture life slowly like the sun. They were born to create the materials for the future. They are the universe's greatest factories for heavy elements. Gold and other precious metals that we desire are, in fact, all waiting for the moment these giants fall. Although they do not create gold at this stage, they are preparing the most essential foundational ingredients. Without the haste and power of these high-mass stars, the periodic table of elements would forever be limited to light and simple elements. We need their pride to have the diversity of the world we have today. Interestingly, because they live fast and die young, these stars usually don't stray too far from where they were born. When we see a cluster of giant blue stars, we know we are looking at a nursery of the universe where these great entities have just recently formed and are enjoying their most glorious moments. The light from them travels thousands of light years to reach our eyes, carrying a message of unparalleled yet fragile power. Now, feel the powerful pulse of space. Imagine yourself floating amidst the blue-white streams of light from a supergiant. You don't feel heat, only an immense majesty. Everything is moving at extreme speeds inside that furnace. Atoms are colliding, fusing, and forging the seeds of metals. These giants know their time is short. Therefore, they do not waste a single second. They shine with all their might, offering all their matter and energy to illuminate the darkness of the galaxy. It is a noble sacrifice in the guise of pride. And it is this sacrifice that will lead to the most dramatic events in the universe in the chapters to come, supernova explosions that can shake both space and time. Let your mind settle down, following the brilliant light as it softens in your imagination. No matter how powerful, these stars are approaching a physical limit that cannot be surpassed. That is when they begin to create iron in their cores. Iron, an element that seems so ordinary, is in fact the executioner that will end the lives of these giants. But that is a story for the next chapter. For tonight, just let the image of these proud blue stars watch over your sleep. Feel the beauty of their power and fierce dedication. The universe is magnificent, and you are a small but incredibly important part of the flow of matter that these giants have created. We will close the chapter on the proud giants here, while they are at the peak of their power. In the next chapter, we will learn about the Iron Wall, the final limit before which even the most powerful stars must bow. Marking the beginning of a terrifying collapse and the birth of the most precious treasures, our journey continues to drift along smoothly, guiding you into a state of deep relaxation. Just let the stars lead your soul. Chapter 11, The Unbreakable Iron Wall. In the infinite silence of space, the proud giant we just spoke of is approaching the final days of its brilliant life. Imagine the star now as a magnificent castle with many layers of defense. If we could cut this star in half to observe it, we would see a fantastical structure resembling the layers of a giant onion. Each layer is a different nuclear furnace, where elements are being forged at dizzying speeds under unimaginable pressure and temperature. In the outermost layer, hydrogen is still quietly fusing to form helium. Deeper inside, the next layers are burning helium to create carbon and oxygen. Deeper still are layers of neon, magnesium, and silicon. The closer to the center, the higher the temperature rises from hundreds of millions to billions of degrees Celsius. The star is now mustering all its remaining strength to stay alive, fighting against the crushing force of gravity that is poised to annihilate it from all sides. Right in the star's core, a critical event is unfolding. Silicon atoms at temperatures of nearly 3 billion degrees Celsius begin to fuse. This is an extremely rapid process. While the hydrogen burning phase lasts for millions of years, the silicon burning phase in the core of a giant star lasts for only about a few short days, and the final product of this process is iron. Iron appears in the star's core like an uninvited guest, but one that carries a message of destiny. In the world of atomic nuclei, iron is a very special element. It possesses a perfectly stable nuclear structure. All elements lighter than iron release energy when they fuse. This is the very power source that pushes outward to keep the star from collapsing. However, iron is a wall that blocks that journey. When iron nuclei try to fuse to create heavier elements, they do not release energy. On the contrary, they consume energy. Imagine the star is like a giant corporation that has operated smoothly for millions of years by turning a profit from producing lighter elements. But now, when the production line reaches iron, everything is turned upside down. The more iron it produces, the more energy the corporation loses. Iron is like a nuclear ash that cannot burn any further, yet is incredibly heavy. That is why scientists call iron a poison to stars. The appearance of iron marks an irreversible endpoint. As the iron core begins to accumulate and grow, the outward push of energy from nuclear reactions suddenly weakens, then disappears entirely. The iron wall has stopped the symphony of light. The star, no matter how large and magnificent, now has no way to fight against its own gravity. Relax your body and feel this threatening stillness. This is the moment when the universe seems to hold its breath. The star's iron core is now about the size of Earth, but its mass is many times greater. With no outward pressure to maintain balance, the iron core begins to become unstable. It is no longer a solid pillar, but a potential black hole waiting to devour everything. Gravity, after patiently waiting outside the wall for millions of years, has now found a crack. It begins to pull all of the star's matter toward the center with an unstoppable force. This moment is like the last domino falling, bringing down an entire brilliant empire. The iron wall is not just the limit of physics. It is the boundary between life and death, between stable existence and the most magnificent explosion in space. You might wonder, if iron is the final stop, then where do gold and silver come from? The answer lies in the very collapse that is about to happen. It is the death of this giant, the shattering of the iron wall under terrifying pressure, that will create conditions so extreme the universe can forge elements heavier than iron. The gold you cherish in your hands is, in fact, the result of a process that overcame this grim limit. Now, breathe steadily and let your mind drift with the final pulse of the star's core. Everything is happening silently beneath the brilliant outer shell. The star still looks stable from the outside, but deep within, the engine has stopped turning. An eerie silence envelops the iron core. It is the quiet before the most terrifying storm begins to rise. In the universe, an ending often carries the seeds of a new, more brilliant beginning. The iron wall may have ended the life of one star, but it is the key that unlocks the galaxy's treasure. Without the dead end of iron, matter would forever be stuck in simpler forms. We need this failure of the star to have the richness of the world around us. Imagine you are observing that star from a great distance, maybe a few light years away. You see it still shining proudly, but you know that inside, an energy crisis is reaching its peak. Iron has won. Gravity has won. And in the next moment, that entire grand structure will collapse inward at 1/4 the speed of light. It's a prospect that is both devastating and magnificent. But tonight, let's just pause here at the threshold of that collapse. Let your soul settle into the stillness of space. You are safe in the embrace of Mother Earth, while somewhere out there, stars are carrying out their noble duty to create matter for all future generations. When one door closes, another opens. The iron wall stopped conventional fusion, but it ignited an even greater material revolution. In the next chapter, we will witness the terrifying moment of collapse as an entire giant star is compressed in the blink of an eye, setting the stage for the birth of a supernova. Our journey continues to drift on, as gentle and serene as the stars above. Just let the thoughts of the universe's grandeur guide you into a deep and peaceful sleep. Chapter 12. The violent moment of collapse. In the eerie silence of the cosmos, the proud giant had reached the end of its endurance. The iron wall we spoke of in the last chapter has completely extinguished the nuclear fire in the star's core. With no outward flow of energy to support it, The star is now like a skyscraper, thousands of stories high, its sturdiest foundation suddenly ripped away. The moment of gravity's complete victory has arrived, initiating the most terrifying collapse nature has ever created. Think of the balance the star maintained for millions of years. It was a tug of war between two giants. On one side, gravity, always trying to crush everything, and on the other, thermonuclear pressure, always trying to push everything apart. When the iron core accumulates enough mass, about 1.4 times the mass of our Sun, the pressure side officially surrenders. Gravity is no longer a gentle pull. It becomes a raging hurricane, pulverizing every barrier. The entire iron core, which was about the size of the Earth, suddenly collapses inward. This collapse happens at an unbelievable speed, about 75,000 kilometers per second, equivalent to 1/4 the speed of light. In less than a tenth of a second, faster than you can blink, a colossal mass of matter is compressed from the size of a planet down to just about 24 kilometers across. Try to imagine the entire Great Mount Everest being crushed down to the size of a single grain of sand. That is the terrifying density occurring here. The pressure is so immense that the structure of atoms begins to break down. Under normal conditions, electrons and protons maintain a certain distance from each other. But in this cosmic press, they are squeezed so tightly together that they merge, transforming into neutrons and releasing an unimaginable number of tiny particles called neutrinos. The star's core has now become a super-dense neutron sphere. At a certain point, these neutrons can be compressed no further. They form a surface as hard as diamond, holding any further collapse. While the core has come to an abrupt stop due to its extreme rigidity, the rest of the star, the massive outer layers, are still plummeting downward at breakneck speed due to inertia. Imagine throwing a rubber ball hard against the concrete floor. When these layers of gas collide with the superdense neutron core, they can go no further. A rebound collision occurs. All the matter rushing inward is violently bounced back out into space, creating a fiery shock wave. This shock wave begins to tear through the star's outer layers from the inside out. It carries more energy than all the light an entire galaxy can emit in a whole year. At this point, the star is no longer just collapsing. It is preparing for a magnificent explosion. The neutrinos released from the core, though incredibly tiny and elusive, provide an extra push to this shock wave in their immense numbers, helping it break through the final dense layers of matter to escape. The feeling at this moment is strange. On one hand, it's a terrible destruction where a great entity is obliterated in an instant. On the other, it is a convergence of the purest energy. It is in these brief moments, as the star's layers are compressed and rebounded, that the temperature soars to tens of billions of degrees Celsius. This is the extreme environment the universe needs to perform its next miracles. Without this terrifying collapse, we would never have enough heat and pressure to forge the heaviest elements. Breathe slowly and feel the rhythm of this transformation. The universe does not destroy in vain. The collapse of the iron core is the price that must be paid to release new seeds into space. When a star dies so violently, it is actually performing an explosion of life. What happens in a thousandth of a second at the star's core is the origin of future gold mines, silver mines, and other treasures. In the quiet darkness of the night, imagine yourself standing at a safe distance, witnessing this majestic moment. A brilliant blue point of light suddenly shrinks, then erupts into a halo of pure white light that pierces the galaxy's darkness. It is the end of one journey, but the beginning of something far more brilliant. The neutron heart of the star now lies there, hot and spinning wildly, while its magnificent robes are flung into the void. This moment of collapse reminds us that sometimes the greatest changes come from the most immense pressures. The star did not surrender to gravity quietly. It gathered everything to create a brilliant counterattack. And from the rubble of this collapse, a supernova will be born, carrying the breath of true alchemists to turn stardust into pure gold. We will close this chapter on the collapse here, as the shock wave begins its journey, tearing through the giant's outer layers. The star is truly shattered, but what it leaves behind will be eternal. The light from this explosion will soon travel across millions of light years to announce to the entire universe the birth of a new generation of matter. In the next chapter, we will step into the heart of the supernova explosion, the star's final solo. It is there that we will see how gold is truly born from the fragments of this collapse. For now, let your mind relax, feel the safety of your small room, while your imagination continues to soar among the wonders of creation. Our journey continues, full of wonder and the peace that comes with knowledge. Chapter 13. Supernova, the final solo. In the vast silence of the universe, when a blue giant falls, it does not go quietly. Instead, it unleashes the greatest explosion nature has ever witnessed, a supernova. This is its final soliloquy, a brilliant and powerful farewell that transforms a single star into the brightest entity in an entire region of the sky. Imagine you are standing at a safe distance, thousands of light years from the star. In the immense darkness, a tiny but incredibly sharp point of light suddenly appears. In just a few short days, that point of light erupts with such intensity that it can emit the light of 100 billion stars combined. If this explosion occurred in our own galaxy, its light could be so strong that we would see it shimmering in the daytime sky, and at night, it could cast the distinct shadows of trees upon the ground. The shock wave we saw in the previous chapter has now torn through the star's entire outer shell and is hurtling into space at speeds of up to 30,000 kilometers per second. This speed is so fast that it takes less than 2 seconds to travel the distance of the Earth's circumference. All the matter the star had accumulated over millions of years, from hydrogen and helium to carbon dioxide, oxygen, and iron, is now cast out in a colossal, ever-expanding sphere. Within that brilliant halo, the temperature erupts to tens of billions of degrees Celsius. This is the universe's ultimate forge. Do you remember the iron wall we talked about? Here, in the moment of the supernova, the energy is so abundant that it can shatter all physical barriers. Powerful streams of neutrons rush forth, like a hailstorm of bullets, penetrating the atoms of iron and other elements. Under this horrific pressure and temperature, atoms begin to frantically devour neutrons. This is the most masterful forging process. In just a few short seconds of the explosion, the universe accomplishes what the star could not in its entire lifetime, creating elements heavier than iron. It is here that the seeds of silver, platinum, and especially gold truly take form. A supernova is not just a destructive explosion, it is a grand alchemist, scattering its treasures into the void. Scientists at the American Space Agency NASA have used modern telescopes like Hubble and James Webb to observe the remnants of these explosions. One of the most famous examples is the Crab Nebula, the result of a supernova recorded by ancient astronomers in the year 1054. To this day, nearly 1,000 years later, that nebula is still expanding and shining, telling the story of a giant's tragic death. Relax your mind and feel the rhythm of the light. A supernova is like a final breath, but one that is full of life. All the gold humanity has ever mined, from the treasures of ancient Egyptian kings to the wedding rings on each person's hand, was all born from these very cataclysmic explosions. We are wearing a piece of the universe's greatest explosion. The light from a supernova is brightest in the first few weeks. Then it slowly fades over many months, even years. But its influence lasts forever. As its shockwave passes through neighboring clouds of dust and gas, it compresses them, triggering the formation of new stars. One star dies so that thousands of others may have the chance to be born. It is an endless cycle of sacrifice and rebirth, a symphony with no end in space. In the quiet darkness of the night, let the image of the supernova's glow soothe your soul. You need not fear its power, for it is so far away, and it is the very source of all the diversity on this planet. Without the final solo of the stars, the universe would be a dull place filled with only simple elements. It is this brilliant departure that has woven the rich tapestry of color and matter that we now enjoy. Now, as that halo begins to expand and fade, the matter within it embarks on a new journey. Gold, silver, and the other precious elements just created are no longer imprisoned in the star's core. They are flying freely among the stars, waiting for the day they might gather once more to form new planets. Let your mind drift like motes of gold dust through the galaxy. Feel the serenity in knowing that even an end can bring such magnificent beauty. The universe always knows how to turn what is most painful into what is most precious. The star's solo has concluded, but its echo will resonate forever in every atom that makes up our world. We will close the chapter on the supernova here. The star has completed its most spectacular performance. In the next chapter, we will delve deeper into the details of the process of gold's creation, the way tiny neutrons changed the destiny of matter in the great forge of the explosion. Our journey continues, gentle and full of poetry. Let your sleep be warmed by the eternal radiance of the stars. Chapter 14. The Gold Forge of the Explosion. In the absolute silence of the night, when we look at an object made of gold, we usually only see its luxurious sparkle. But few know that for the universe to create a tiny speck of gold, it had to undergo a violent forging process in the final seconds of a giant star's life. If the last chapter showed us the magnificent glow of a supernova, this chapter will decode the secret hidden deep within that light. The rapid neutron capture process, also known as the R process, where gold is truly born. Imagine again the moment the supernova is at its peak. As the star is torn apart, it releases not only light, but also a colossal amount of neutrons at an unbelievable density. In this terrifying forge, the temperature reaches billions of degrees Celsius, and the pressure is so intense, it could compress anything. Neutrons, particles with no charge, rush out like a hailstorm of bullets at extreme velocities. They are not repelled by atomic nuclei. On the contrary, they fly straight into the heart of the iron atoms that were previously created. Normally, under stable conditions, it is very difficult for atoms to change their nature. But in a supernova, this rule is broken. An iron atom, which has only 26 protons, is suddenly bombarded by a barrage of neutrons. In a thousandth of a second, the iron nucleus swallows tens, even hundreds of neutrons before it can even realize what is happening. This process occurs so quickly that is called the rapid neutron capture process. However, accumulating too many neutrons makes the atomic nucleus unstable. To find balance again, a wondrous physical phenomenon occurs: beta decay. In that instant, the excess neutrons inside the nucleus begin to transform. They release an electron and turn themselves into a proton. Remember, in the universe, the number of protons is what defines an element's identity. As the number of protons increases, the original iron atom is no longer iron. It begins to climb the higher rungs of the periodic table. From 26 protons, it leaps to 40, 60, and finally stops at the brilliant number 79. The moment the atomic nucleus reaches the milestone of 79 protons, gold is officially born. This is a miracle of cosmic alchemy, where the waste of the star's core is compressed and bombarded to become treasure. This entire process, from iron to gold, takes place in just a few short seconds during the supernova explosion, but it consumes more energy than the light of an entire galaxy combined. It is because it requires such an extreme and rare condition that gold is one of the rarest elements in the universe. If hydrogen and helium are the endless sands on a beach, then gold is the rare gem hidden deep at the bottom of the ocean. Every atom of gold in the ring you wear or in the electronics of the phone you use carries a birth certificate from a distant supernova. They are travelers who have journeyed across billions of light years, carrying the warmth of a billion-degree forge to reach human hands. Along with gold, the supernova forge also creates other heavy elements like platinum, silver, and even uranium. All are forged from the same recipe: a combination of horrific pressure, an intense flood of neutrons, and the magical transformation of the nucleus. As the supernova's glow gradually fades, these newly formed gold atoms are no longer imprisoned. They ride the shock wave, flying into interstellar space at thousands of kilometers per second, beginning an endless journey among the stars. Relax your mind and feel the grandeur of this connection. You are lying here, in the silence of the night on a tiny planet. Yet, you possess fragments of the greatest explosion in the galaxy. Gold is not just matter, it is the fossil of a dead star. It is proof that the universe always knows how to recycle what is broken into what is most beautiful. It is a wondrous feeling to know that the luxury and splendid beauty of gold originated from an event so devastating and tragic. Scientists at the American Space Agency, NASA, using modern spectrometers, have confirmed the presence of gold in the remnants of stellar explosions. They see characteristic bands of light that tell the story of the rapid neutron capture process taking place in the most distant corners of the cosmos. These discoveries not only enrich our knowledge, but also deepen our admiration for the intricate workings of the cosmos. Nothing is random. Every atom has its own heroic history. Now, imagine tiny particles of gold dust drifting lazily in the deep darkness of space. They are like tiny sparks of fire in a vast, cold, black ocean. They are no longer as hot as when they were first born, but have gradually cooled, waiting for billions of years to be gathered together once more. The journey from the core of a star to human hands is an epic saga of time and space, where the universe's patience is infinite. Gold is created in violence, yet it brings us a sense of eternity and peace. It is a beautiful balance. As you drift off to sleep, let the image of that brilliant neutron forge fade from your mind, giving way to tranquility. You are part of this universe, and the most precious things in the universe are present all around you, and even within you. We will end our chapter on the gold forge here. The star has exploded, gold has been created, and is beginning its journey of dispersal. But the universe holds another secret, a place even more terrifying and powerful than a supernova for creating even more massive amounts of gold. It is the collision between the corpses of dead stars, the neutron monsters of space. In the next chapter, we will explore the most precious treasures created from the cataclysmic collisions of neutron stars. It will be a chapter about the raw power and the ultimate wealth of the galaxy. Our journey continues to drift smoothly, guiding you into a deep and peaceful sleep. Chapter 15. The collision of stellar corpses. In the deep darkness of the galaxy, after the supernova explosions have faded into the past, they sometimes leave behind unbelievable remnants. Neutron stars. Imagine an object with more mass than our Sun, yet compressed into a tiny space only about 16 to 24 kilometers wide, about the size of a small city. A single teaspoon of material from this star could weigh up to 1 billion tons. They are monsters of density, extremely dense stellar corpses. But our story doesn't end in solitude. Sometimes, in the vast universe, two such neutron stars are born together and orbit each other in a death dance that lasts for billions of years. They spiral through space, each rotation pulling them a little closer together. In the process, they create tiny ripples in the very fabric of space and time, which scientists call gravitational waves. These ripples are like the circles of water that spread when you throw a stone into a still pond, carrying a message of a cataclysmic event about to happen. The closer they get, the faster they spin, reaching a dizzying pace of hundreds of times per second. And then, the fateful moment arrives. These two stellar corpses collide at 1/3 the speed of light. That impact is not just an explosion. It is an event that shakes the cosmos, releasing a colossal amount of energy that astronomers call a kilonova. If a supernova is an efficient gold forge, then a kilonova is a massive factory producing gold on an unimaginable scale. When two neutron stars slam into each other, a huge amount of super-dense neutron-rich material is ejected into space. In this environment of incredibly high neutron density, the rapid neutron capture process occurs with maximum efficiency. Atoms of gold, platinum, silver, and other heavy elements are forged in massive quantities in the blink of an eye. Scientists estimate that in just one such collision, the amount of gold created can be 10 times the mass of the entire Earth. Try to imagine a treasure that enormous floating among the stars. This is the primary source of most of the gold we have today. Gold doesn't just come from the final breath of a single star. Most of it comes from the violent merging of two dead stellar souls. This grand event is no longer just a theory. In 2017, scientists at the LIGO and Virgo gravitational wave observatories detected for the first time the ripples in space-time from a neutron star collision 130 million light-years away. Shortly after, Telescopes like Hubble and other NASA instruments turned towards that direction and saw the brilliant glow of the explosion. It was the first time humanity had witnessed a giant gold forge in action in the galaxy. Take a deep breath and feel this wonder. Do you see the connection? About 130 million years ago, while dinosaurs still roamed the Earth, in a distant part of the universe, two stellar corpses collided to create a tremendous amount of gold. The light and gravitational waves from that event traveled through the vastness of space across millions of galaxies to reach Earth at the exact moment we had the technology to understand it. Gold is a symbol of wealth and power. But in the eyes of the universe, it is the result of ultimate sacrifice and convergence. Two stars had to live brilliant lives, die in supernova explosions, and then their remnants had to find each other and merge into one to create those sparkling dust particles. Every tiny piece of gold carries within it the power of extreme gravity and the transformation of time. Now, let your mind drift along with the shimmering streams of matter radiating from that collision. They are no longer hot atomic nuclei, but have cooled, becoming fine particles of gold dust drifting in the void. They will journey through clouds of gas, weave through star systems, and wait for billions of years to become part of a new world. Perhaps some of the gold in the watch you're wearing, or in the most sophisticated electronic components, is a legacy from such a collision. We are truly touching the remnants of an event that vibrated space-time itself. That feeling is so soothing and mystical, isn't it? The universe never wastes anything. Even the death of stars is used to create the most magnificent treasures. Relax your body, feel the tranquility of tonight. You are lying in the protective embrace of Earth's atmosphere, far from the terrifying upheavals of space, yet still connected to them through every atom that makes up the world around you. The stellar corpses collided to create matter, and we are here to contemplate and appreciate that beauty. As the light of the kilonova explosion fades, the gold dust particles begin their long journey through interstellar space. They will not travel alone, but will join trillions of other dust particles to write the next chapters of life. It is a journey from chaos to order, from ashes to lush green planets. We will close the chapter on a collision of stellar corpses here. A great treasure has been released into space. In the next chapter, we will follow these dust particles as they become lonely travelers crossing galaxies in search of a new home. Our journey continues to drift, as gentle as a lullaby from the stars. Let your sleep be deep and peaceful, amidst countless shimmering particles of stardust. Chapter 16, Travelers in Space. After the thunderous roars of a supernova or the fiery collision of neutron stars, the universe seems to fall into a strange tranquility. The brilliant flashes of light gradually fade, giving way to a new journey, a silent but meaningful one. The newly forged atoms of gold, silver, platinum, and even pure carbon dioxide now officially become solitary travelers, beginning their journey of myriad miles through the vast expanses of the galaxy. Imagine how tiny these particles are. They are smaller than a grain of sand, smaller than a strand of your hair, yet each one contains a grand story of survival. They are no longer imprisoned in the billion-degree heat of a star's core. Now, they are drifting in the interstellar medium, a region of space between stars that seems empty but is actually a vast reservoir of matter for the universe. Our travelers do not move alone or at random. They are propelled by the force of the shock waves left over from the explosion. Picture a colossal, invisible wind blowing these gold dust particles trillions of kilometers away. Their speed can initially reach tens of thousands of kilometers per hour. But as they move deeper into the cold gas regions of the galaxy, they begin to slow down, drifting lazily like flower petals falling into an autumn stream. On this journey, the bone-chilling cold of the universe envelops everything. The temperature here can drop to negative 270 degrees Celsius. In this extreme cold, tiny dust particles begin to undergo magical changes. Carbon dioxide atoms can combine to form more complex molecules. Some gold dust particles might collide and stick to tiny rock fragments or fragile ice crystals. They become tiny time capsules, perfectly preserving the universe's most precious minerals inside their icy shells. The distance these travelers cross is a number the human mind can scarcely comprehend. To travel from where they were born to a neighboring star system could take them millions of years. Throughout that immense span of time, these dust particles witness the birth and death of countless generations of other stars. They weave through the giant dust pillars of the Eagle Nebula or drift around the pink ribbons of the Carina Nebula, frequently captured by NASA's James Webb Telescope. The most miraculous thing is that, despite being alone in the vast darkness, these travelers are never lost. The laws of conservation in the universe ensure that every atom of gold and carbon dioxide continues to exist. They are like seeds waiting for fertile ground to sprout. The universe is like a diligent farmer who, after each brilliant harvest from the death of a star, casts these precious handfuls of seed dust into space, waiting for the right moment to begin a new cycle. Sometimes, these dust particles are drawn into denser regions of space, where gravity once again begins to assert its power. They gather into enormous, cold clouds of dust. Here, the gold particles from neutron star collisions and the carbon dioxide atoms from white dwarfs begin to mingle. This is when the travelers take a temporary rest, preparing for an even more brilliant new chapter. The formation of a new solar system. Breathe slowly and feel the serenity of this journey. Do you see? Our existence is not an isolated event. Every gold atom in the ring you touch, every carbon dioxide molecule in your breath, was once a lonely traveler, just like these. They crossed the darkest regions of space, endured the most bitter cold, only to one day converge on this green planet. The feeling of drifting among the stars is so peaceful. There is no noise, no pressure, only the absolute freedom of matter. These precious dust particles are the very link between the glorious past of the stars and the brilliant future of the planets. They carry the last view of stars that have died, entrusting the hope of a new life that will be forged from these very precious fragments. As you drift off to sleep, imagine you are also a tiny traveler, floating among the sparkling galaxies. The minuscule gold dust particles are like little glimmers of light, guiding you into the realm of dreams. The universe is vast, but not alien, because you yourself are made from the most precious materials these travelers have brought. Everything is unfolding according to the rhythm of nature, slowly, deliberately, and full of grace. The travelers in space are still diligently moving out there, even as we sleep. They are a testament to the fact that beauty and value always endure through time. One day, these particles of gold will no longer be alone. They will find each other, and together, they will build mountains, rivers, and even civilizations. We will close the chapter on the travelers here. The stardust has traveled a very long way, and now it is beginning to gather. In the next chapter, we will witness the magical moment when these remnants become the building blocks for the formation of our solar system. That is when the gifts from the universe officially find their home. Our journey is still continuing, as gentle and soft as a lullaby from the distant stars. Let your sleep be deep and peaceful. Chapter 17. Legacy of the Remnants. After millions of years of drifting like homeless travelers in the darkness, the particles of gold, carbon dioxide, and other precious elements began to find their resting place. Imagine a vast region of space about 4.6 billion years ago. In the place that is now our solar system, there was only a giant, cold, and quiet cloud of gas and dust known as the solar nebula. This cloud was not a completely new beginning from nothing. In fact, it was a great cosmic scrapyard, containing the remnants from the deaths of many previous generations of stars. Within that hazy cloud were ancient hydrogen atoms from the dawn of the universe, but also brilliant gold particles from neutron star collisions and pure carbon dioxide fragments from cooled-down white dwarf stars. That entire precious legacy was waiting for one final push to be reborn into a new form. That push may have come from a supernova explosion of a nearby star. The powerful shock wave from that blast swept through our dust cloud, disturbing the stillness and causing gravity to once again exert its power. The cloud began to contract, spinning faster and faster. At the center, matter became dense, heated up, and formed the sun, our brilliant source of light. But the miraculous story of gold and diamonds lies in the leftover material, swirling around the young sun in a giant protoplanetary disk. Picture this disk as a great river of matter. Near the center, where the sun was radiating immense heat, only the most heat-resistant materials could survive. These were rock and metal, the very heavy dust particles forged in the depths of stars that we have followed for the past 16 chapters. The tiny gold particles, stable iron atoms, and silicon rock fragments began to collide and stick together. This process was incredibly slow but immensely powerful. Tiny dust particles clumped into pebbles. Pebbles crashed into each other to form large rocks. And then those rocks, under the pull of gravity, created the solid rocky planets like Mercury, Venus, Earth, and Mars. Because gold and platinum are very heavy elements, they tended to be pulled toward the center of the young planets while they were still in a molten state. On our Earth in its early days, it was a vast sea of fire. Rivers of molten gold and iron sank deep into the core, located thousands of kilometers below the surface. If not for later events, gold might have remained forever hidden in the heart of Mother Earth. But the universe always has surprising plans. As the Earth gradually cooled and formed a hard, rocky crust, collisions from meteorites carrying gold and precious stones from space continued to rain down, enriching the outer crust that we can touch today. As for carbon dioxide, the seed of diamonds, it also found its place. Some of the carbon dioxide evaporated into gas, but a large portion was trapped deep within the Earth. Under the immense pressure of hundreds of thousands of kilometers of rock and the high temperature radiating from the Earth's core, carbon dioxide repeated the crystal arrangement process it once performed inside white dwarf stars. Diamonds were formed deep underground, carrying within them the perfect structure of the cosmos, waiting for geological upheavals to bring them closer to the surface. Take a deep breath and feel the magnificence of this legacy. You are standing on a planet built from the ashes of dead stars. Every great mountain, every green field, and even the precious veins of gold hidden deep in caves are all gifts from the galaxy's tragic past. Our solar system is not an isolated oasis, but a museum of matter, preserving treasures forged in the harshest nuclear furnaces. The distances from the Sun to the planets are also arranged harmoniously. Earth is located in just the right spot, about 150 million kilometers from the Sunday. At this distance, the warmth from our mother star helps maintain water in liquid form, allowing the carbon dioxide atoms from stardust not only to form diamonds but also to combine into more complex molecules, the origin of life. You see, the same type of carbon dioxide atom, if compressed deep down, becomes a diamond. But if it stays on the surface under the gentle sunlight, it creates our very breath and heartbeat. It's so peaceful to think that everything around you shares a common history. The gold ring you wear, the sparkling gemstone, or even the iron in your blood, they were all once together in the same cold nebula cloud before the solar system took shape. They journeyed together for billions of light years to finally be reunited here on this beautiful green planet. As you drift off to sleep, imagine the formation of Earth as a process of refining the finest essence. The universe gathered the best from the death of giants, entrusting them to tiny dust particles, and using gravity to mold our home. The legacy of these remnants is not ruin, but the most magnificent rebirth. The sun now shines steadily, the planets have found their orbits, and precious treasures have been settled deep within the Earth. The journey of the stardust has reached a happy conclusion, where it no longer drifts alone but has become part of a living entity. We will close the chapter on the formation of the solar system here. Everything is now ready for the arrival of eternal beauty. In the next chapter, we will return to Earth, venturing deep into the heart of Mother Earth to learn about the final journey of carbon as it transforms into sparkling diamonds under immense pressure. Let your mind be soothed by the steadfastness of the Earth and the compassion of the sky. May you have a deep sleep enveloped in the great legacy of the stars. Chapter 18. Diamonds from the heart of Mother Earth. In the stillness of the night, when we look at a sparkling diamond, we often see only its magnificent beauty. But did you know, each of those diamonds is actually a messenger from a distant past and from the harshest forges of the galaxy. After the carbon dust from dead stars gathered during Earth's formation, a large portion of it was buried deep beneath the crust we stand on. There, another miraculous journey of transformation began. A journey lasting billions of years to turn dark ashes into timeless treasures. Imagine you are traveling through the hard rock layers of the Earth, going deep below the fragile crust. The deeper you go, the hotter the space becomes, and the pressure becomes suffocating. To create a diamond, nature requires an incredibly special environment, located at a depth of about 150 to 200 kilometers beneath the surface. At this depth, the temperature is typically maintained at around 1100 to 1300 degrees Celsius, and the pressure is tens of thousands of times greater than the air pressure on the surface. In this giant pressure cooker of Mother Earth, carbon atoms begin to reorganize their lives. Instead of being scattered chaotically as in pieces of coal or lead, under this crushing pressure, they are forced tightly together. Each carbon atom bonds extremely tightly with 4 surrounding atoms, forming a perfect cubic crystal lattice structure. This is the most stable chemical bond in nature, and it is this structure that gives diamonds their unrivaled hardness, making it impossible for any other material to scratch them. This journey requires the infinite patience of time. The diamonds that humans mine today were mostly formed between 1 billion and 3.5 billion years ago. Just imagine, while those diamonds were taking shape deep within the Earth, on the surface, life had not yet appeared or consisted only of the simplest single-celled organisms. They lay there, in the darkness and heat of the mantle, perfectly preserving the carbon atoms that were born in the cores of giant stars that exploded billions of light years away. But how could these gems, lying hundreds of kilometers deep, ever reach human hands? The Earth does not keep its treasures hidden forever. Through special and extremely powerful volcanic eruptions, known as kimberlite pipes, the diamonds were taken on a high-speed elevator ride up near the surface. These eruptions carry magma from deep within the Earth, pushing the diamond-bearing rocks upward at a tremendous velocity. This rapid journey is crucial. If the diamonds were to rise too slowly, the gradual decrease in pressure and temperature would give the carbon atoms time to rearrange themselves into graphite, the soft material we use as pencil lead. A diamond retains its beauty and hardness only when it is brought out of its forge suddenly, as if a secret of the universe was stolen and brought to the surface before it had a chance to transform. Now, let your mind relax and feel this incredible connection. A diamond in your hand today is the result of 2 great forgings. The first was in the 100 million degree furnace of a dying star in the vastness of space. The second was in the silent pressure over billions of years within Mother Earth. A diamond is the perfect intersection of astronomy and geology, proof that our Earth has always cherished and preserved the precious gifts from the cosmos. When you touch the cool, smooth surface of a gemstone, remember that you are touching atoms that once journeyed through distant galaxies. You are touching eternal time and the incredible power of nature. A diamond doesn't just sparkle because it reflects light. It sparkles because it carries within it the memory of the stars. Under the soft light of the room, let the image of perfect carbon crystal lattices guide you to sleep. There is no need to rush, for even diamonds need billions of years to shine. Every weight and every pressure in this life, when viewed from the perspective of a star or a gemstone, are merely necessary steps to create something enduring and beautiful. Feel the solidness of Mother Earth beneath your back. The Earth is cradling you, just as it has cradled and forged diamonds in its heart for eons. You are safe, protected within a wondrous and benevolent system of the universe. We will close the chapter on the journey of diamonds here. The treasure has been brought to the surface, waiting to be found and celebrated. But our story still has another brilliant piece: gold. Gold is not forged in the earth like diamonds. It comes to us in a different way, like the tears of stars falling upon the world. In the next chapter, we will explore gold, the precious metal that never tarnishes, and how it weaves its way into veins of rock, waiting for humanity to discover it. It will be a story of rarity and the eternal beauty of these star tears. Our journey continues, flowing gently and smoothly like a lullaby from Mother Earth. Let your sleep be deep and peaceful, amidst dreams sparkling with the light of diamonds. Chapter 19. Gold, the tears of the stars. In the silence of the night, gold always appears with a regal and unfading beauty. Unlike diamonds, which are molded from carbon atoms already present on Earth, gold is a true visitor from the most distant reaches of space. As we learned in previous chapters, gold is forged in supernova explosions or the cataclysmic collisions of neutron stars, but there is a mystery few people know. Why does something created from cosmic violence lie so peacefully in veins of rock or at the bottom of small streams on our blue planet? The story begins about 4.6 billion years ago, when the Earth was still a blazing molten sphere. During this early stage, a phenomenon scientists call the iron catastrophe occurred. Because gold is a very heavy and extremely iron-loving element, almost all the gold present at that time was pulled by iron, sinking together deep into the planet's core. Scientists estimate that the amount of gold in the Earth's core is so vast that if spread evenly, it could cover the entire surface of the planet with a layer of gold half a meter thick. However, that gold will forever remain beyond human reach. So, where did the veins of gold, the gold we mine today, come from? The answer lies in another dramatic event called the Late Heavy Bombardment. About 4 billion years ago, after the Earth's crust had gradually cooled and solidified, a colossal meteor shower rained down upon our planet. These meteorites were actually debris from the formation of the solar system, carrying with them precious gold dust from ancient stellar explosions. It was this meteor shower that seeded the outermost crust of the Earth with gold, leaving a brilliant legacy for humanity. However, gold is not scattered about easily. After falling to Earth, gold needed a process of collection by nature over millions of years. Imagine streams of scalding water weaving deep into the cracks of the Earth's crust. This hot water, at temperatures of hundreds of degrees Celsius and full of minerals, dissolved tiny gold particles and carried them along. When this water cooled or encountered suitable chemical conditions, the gold would precipitate out, clinging to veins of quartz rock, creating the shimmering veins of gold hidden within mountains. The preciousness of gold lies not only in its cosmic origins, but also in its noble nature. Gold is one of the least reactive metals. It doesn't oxidize, it doesn't rust, and it never loses its luster, even after thousands of years underground or at the bottom of the ocean. It is this resilience that has made gold a symbol of eternity. When you hold a piece of gold in your hand, you are truly touching a substance that has remained almost unchanged since the moment it was forged in the neutron furnace of a long-gone star. Take a deep breath and feel the preciousness of every gold atom. They have traveled across trillions of kilometers, endured the bone-chilling cold of interstellar space, then survived fiery collisions with the atmosphere to finally lie silently in the grain of a rock, waiting to be found by humans. Gold is like the tears of stars that fell to the world, carrying a message of the universe's limitless creative power. In the currents of history, gold has led humanity on expeditions, built magnificent empires, and inspired countless works of art. But beyond its material value, gold is an unseen connection. That thread connects our hands to the greatest events of space and time. When a goldsmith forges a ring, they are not just working with metal. They are shaping the remnants of a supernova explosion. Relax your mind and imagine the particles of gold sleeping silently in the cracks of rock beneath your feet. They are so patient and quiet. It took the universe billions of years to create them, and it has taken the Earth billions of years to store them. Everything takes time, and preciousness always goes hand in hand with patience. It's a peaceful feeling, isn't it? You are enveloped by a world full of exquisite treasures, distilled through the many ebbs and flows of creation. Its brilliant yellow color is like crystallized sunlight. But unlike sunlight, which fades when night falls, this golden hue is eternal. It reminds us that even in the deepest darkness of the earth, wondrous and radiant things always exist. Yangzi, gold is not just an asset, it is proof that the demise of a star is never meaningless. Its passing has left us with the most magnificent seeds. Tonight, as you lie here, Let your mind drift along the brilliant veins of gold weaving through the stone. Feel the stability, the certainty, and the permanence of this metal. You are part of a planet that carries within it the treasures of the cosmos. This connection is profound and brings with it a strange sense of peace. Every atom in your body and every particle of gold on this earth share the same brilliant origin. We will close the chapter on the tears of the stars here. Gold has found its place and the diamonds have been forged. All the most precious materials are ready. In the final chapter, we will bring everything together and realize a truth that is even more astonishing. It is not just gold and diamonds, but we ourselves who are the children of stardust. Our journey is approaching its final notes, gentle and full of poetry. Let your sleep be warmed by the eternal golden light from the distant realms of space. Chapter 20. We are stardust. In the stillness of the night, as your breath becomes slow and steady, join me on a journey back into your very self. For the past 19 chapters, we have spoken of radiant gold and sparkling diamonds as extravagant treasures. However, if you look through the eyes of a cosmologist, there is a treasure far more precious and complex in existence right now. Your own body. The truth is, every cell, every atom that makes you who you are, carries within it an ancient history originating from the very ends of space and time. Through the Great Sloan Digital Sky Surveys, astronomers have performed spectroscopic measurements on hundreds of thousands of stars and compared them with the elements in the human body. The results show an astonishing match. About 97% of the human body's mass is made up of elements like hydrogen, oxygen, carbon, nitrogen, phosphorus, and sulfur. Except for hydrogen, which was born in the moment of the Big Bang about 13.8 billion years ago, all the other elements share a common birth certificate. They were forged inside the nuclear furnaces of stars. Think about the red blood flowing through your veins. That red color comes from the iron atoms in your red blood cells. Do you remember the iron wall we talked about in chapter 11? Every iron atom in your body today is a remnant from the core of a giant star that collapsed billions of years ago. That star had to sacrifice its brilliant life in a terrifying supernova explosion to release these iron particles into space, only for them to converge billions of years later and bring life to you. You carry within you a fragment from the heart of a cosmic giant. Next, feel the strength of the skeleton that supports your body, the calcium in your bones, the oxygen you are now breathing into your lungs, or the carbon, the very thing we saw create precious diamonds, were all crafted in the kitchen of cosmic alchemists. When you touch your skin, you are touching stardust. When you look into the eyes of a loved one, you are seeing atoms that once shone brightly in the middle of the galaxy. The famous scientist Carl Sagan once said beautifully, "We are made of star stuff." This connection is not just a chemical coincidence. It is a deep emotional bond between humanity and the void. The universe is not a distant, cold, and empty place. The universe is our mother, the place that gestated and nurtured every one of our atoms over billions of eons. The journey of a speck of dust from a supernova explosion, drifting for millions of light years, crossing trillions of kilometers to finally land on Earth and become a part of your breath, that is the greatest miracle, one that no religion or myth can compare to. Relax your shoulders and feel the wonder of existence. Do you feel more magnificent? You are not small in this vast universe, because the universe itself exists within you. All your joys, sorrows, thoughts, and dreams are being carried out by stardust that is billions of years old. We are the universe's way of contemplating itself. Through your eyes, the universe is gazing at the beauty of the nebulae. Through your intellect, the universe is gradually understanding its own laws. In this chapter, I want you to cherish yourself the way you cherish gold and diamonds. If gold is rare, then life is infinitely rarer. It took a perfect arrangement over billions of years. From neutron star collisions to the formation of the solar system, to create an environment gentle enough for stardust to combine into a being with a soul. You are the most intricate masterpiece of the cosmic alchemist. The night has grown late, and the space around you is now so peaceful. Imagine the light from distant stars passing through your window, gently stroking your skin. That light carries a message from our siblings still shining high above. They say that even though we are millions of light years apart, we share a common origin. The death of a star is not an end, but a sacrifice to create life. And your life is the most brilliant legacy of the stars that have faded. As you sink deep into sleep, let your mind melt into the vastness of space. Feel yourself floating like a speck of golden dust among the sparkling galaxies. There is no more pressure, no more worries, only a pure connection to your cosmic origins. You are entering a long sleep, just as the stars slept for billions of years before awakening to create this world. Our 20-chapter journey comes to a close here. We have traveled from clouds of dust to terrifying explosions, from the deep heart of the earth to the very ends of the human soul. Hopefully, these stories have given you a new perspective on the world, a sense of peace in your soul, and beautiful dreams of the stars. Now, close your eyelids. Let your breath be as free as the wind in space. You are stardust, and stardust must eventually rest to prepare for new journeys. The earth is embracing you, the moon is watching over you, and the entire universe is smiling down on you. Farewell to the journey of the stars. I wish you a deep sound and peaceful sleep in the arms of Mother Universe. Sleep well.